Hi friends, good morning. Today we are going to discuss how we can represent areal element, length element and volume element of a cylinder using cylindrical coordinates. Using cylindrical coordinates. In the last lecture we have seen what are the cylindrical coordinates, that is r, phi, z. So I am recommending to watch the last video before coming to this. Now how we can represent length element like this? Before discussing, we can come to a figure. So length element of a cylinder, how can we derive like this? That we are going to check. So here I have given a cylinder here, and this is the representation of coordinates, cylindrical coordinate. So I can make a cylinder here for more convenience. So if I consider a cylinder here, of radius like this. So if I consider a cylinder like this, so to measure, to locate this point, I need this z and this phi, and this is our r, that is parallel to this, so this also r. That we have seen in the last class. Now suppose you are increasing a small d phi. See, here you can see, if you consider the rotation is like this, so I am considering the natural axis is like this. So this is our natural axis of the cylinder. So this I am taking as z. This is our z axis. Now you can see the phi angle. This is the angle phi. This is the angle phi. So if the entire angle is phi, you take this as phi. So we are taking phi, that is in the anti-clockwise direction, right? So it can take from 0 to 2 pi. So this is a small angle d phi, right? This is a small angle d phi. So this is the radius. So what about this? By considering this arc, that is radius into angle, so this width is r d phi. Now if I am considering a small elemental height, it is in the direction of this z, so I can consider this as dz. Now this is our r, right? This is our r. So if I am increasing a small dr, that is dr, so dr is in this direction. Dz is in this direction, and this phi is increasing, phi is coming like this. So phi is in this direction, so these all are perpendicular to each other. Now so you can see from the figure all these values. Now I can clear the drawings. Now what is the area produced by? So here you can see, by increasing this dr and this d phi and this dz, we have a small volume is created here. Now I am representing what is this. So length element, so we can think of about length. See, this is the length dr increased, so its direction is r cap. So dl r is equal to, I can write as dr r cap. Now what is the length increased in the z direction? So that is dz, its direction is z cap. So I can write as dl z, that is equal to dz z cap. Now we have one more. In the direction of this d phi, we have a length here. Okay, that is r d phi phi cap. So phi cap is increasing in this direction. So I can write this as dl phi is equal to r d phi phi cap. Okay. So I can represent this length element as, that is, dl is equal to drr cap plus dz cap plus r d phi phi cap. Okay. So this is the length representation in cylindrical polar coordinates. Okay. Now similarly we can represent the area and volume. Okay, so let us go to how we can represent area and volume. Okay, see here you can see an area element on the surface is created this. Okay, what is its direction? Its direction is, it is in this direction. Okay, so this is r direction. R is increasing like this. Okay, this is in the direction of r, so I can give the direction as r cap. Now what is this area? Area is equal to length into breadth, right? So it is length into breadth. So our length is this, that is length is r d phi. Okay, so this, okay, r d phi, and breadth is dz. So small areal element I can write as r d phi dz, r d phi dz. Okay, now what is the direction? R cap. Okay, now similarly we can represent, and you can check if you integrate this, what you get. If it is true, if you integrate, this is a small elemental area on the surface of the cylinder. If it is true, when you integrate this, you will get the curved surface area of the cylinder. So if this height is h, so what is the curved surface area of the cylinder? That is 2 pi. If its radius is r, 2 pi rh. So let us check when we can integrate this. When you integrate this, so here d phi and dz is the variable, and if you consider this area, this r is a constant, that is the radius, right? So I can give this small r I can give as r, and a double integral. This d phi and dz is varying. So for a height h, what is the value of this z? It is varying from 0 to h. Okay, so dz is varying from 0 to h. What is the value of d phi? D phi is varying from 0 to 2 pi. Phi is varying from 0 to 2 pi. D phi dz. Okay. Now see, when you integrate this, you will get r into d phi on integration, you will get phi 0 to 2 pi, and dz on integration you will get z, and it is limit is 0 to h, that is r into 2 pi into h. So you have 2 pi rh. Okay, so it is correct. Okay, so this area on the surface, areal element on the surface of a cylinder, you can represent like this. Okay, now let us check how volume element can be represented. Okay, so let us go to this. What is volume? Volume is equal to length into breadth into height. Okay, so this is our length. Okay, that is r d phi. Okay, and this is our height, that is dz, and this is our breadth. Okay, that is dz, and this is our height. Okay, that is dr. So volume element of, we can represent r d phi dz dr. So we know the volume of a cylinder is pi r square h. So if this volume element is correct, okay, when you integrate this, we will get pi r square h as the volume. Okay, so here you can see, let us check. So here dv, so volume means triple integral. Okay, so 3 variable, so triple integral, so volume is equal to triple integral. So if its radius is 0 to r, so the radius is varying from 0 to r, and phi is varying from 0 to 2 pi, and z can vary from its height. I am considering h. Okay, cylinder height is h, so it can vary from height maximum h, 0 to h, r d phi dz dr. So I can integrate this. Okay, let us go to blackboard. Okay, so this I can write as integral 0 to r dr, integral 0 to 2 pi d phi, and integral 0 to h dz. So when you apply limit, integrate and apply limit, r square by 2 into 0 to r into d phi on integration phi, which is on applying limit 0 to 2 pi, and dz on integration z, that is 0 to h. Now by applying the limit, this is r square by 2, this is 2 pi, and this is h. So you got pi r square h, right? So the volume element which we have derived, that is correct. Okay, so this is representing the volume element. Okay, so the volume of a cylindrical element we can represent like this. Okay, now let us go to the main screen. Okay, so these are the area element, volume element, and length element we have already discussed. Okay, so r d phi dz dr, and here they have shown that this side volume means the same volume, and top and bottom means this volume, right? This volume. Okay, so this volume means, so this is dr and this is r d phi. So this volume, see that also you may check when you integrate this particular area, you will get the, so if you take a cross section like this, if you increase this area, what you get? You will get a circle area. Okay, so you expected to get pi r square, you may check that. So this area is this breadth is dr and this length is r d phi. Okay, so you can, this area dA is equal to this bottom side. Okay, if you consider the bottom side, area is r d phi dr. Okay, so if you integrate this, what you get? A is equal to areal double integral, that is 0 to r and phi only variable. Okay, that is, what is phi? Phi is varying 0 to 2 pi, and what is this? r dr d phi. Okay, when you integrate this r, you will r dr r square by 2, 0 to r, and d phi on integration you will get phi 0 to 2 pi. Okay, that is r square by 2 into 2 pi, so pi r square. So you will get the area of this circle. Okay, so when you expand this area, you will get the complete this circle. Okay, a cross section of the cylinder will produce a circle which includes this small elemental area. Okay, so that is correct. So this way we can represent the areal volume element in cylindrical coordinates. Okay, so in these sessions, so the last 6 videos we have discussed what is Cartesian coordinate system and how can we represent length, area and volume using Cartesian coordinate system, and then we have discussed spherical polar coordinates and how can we represent area, volume and length in spherical polar coordinates. Okay, elements in spherical polar coordinates, and for cylinder also we have derived the same. Okay, now in the next session we will discuss some basic concepts about vector algebra like dot product, cross product, and its physical significance like different operators, divergence, curl, and theorem associated with, okay, Stokes theorem, divergence theorem. And then we will come back to this coordinate system again. There we can represent these divergence, curl operators, Laplacian operators, all in spherical polar coordinates. Okay, so anyway, thank you.